Alrighty, so in today's lesson, we're going to go over chapter 1, but 1.2 of chapter 1 before we head to chapter 2. This is our measures of variability and different means and sample variation and sample space as well too. So for starting off, we're going to start off with some sum notation. So sum notation is all it is basically, let's put formulas in red, which equals the sum of all values of n, which is the number, I equals 1, so xi. So this is our value. Xi of our sum notation equals x1 plus x2 plus x3, and this could go out to infinite x number of n's. So all it is just adding everything that we have and all the data together. So for example, let's say we have an x1 value of 5, 9, and 12. So what we have to do first, but here's the problem with this one. Our sum value is squared. So what we're going to do, we're going to add, every time we do math, we do 5. So 5 plus 9 plus 12, which if we pull out our calculator, will equal 26. But now we have to square 26 due to our value. So now 26 squared equals 676. So that's our answer for our sum notation. So basically anything that's a sum, and squaring it, or depending on how many values there are, where this 3, coincidentally, equals 3 over x and 3r. So using all 3 for our x values. So as we go down, we're going to go over our sample mean or our average, which is expressed by x with the little hat on its head, right? So that formula equals x mean equals xi. So the sum of all the x values, which we can find in the numerator, and all divided by the number of values, which is denoted by n. An example of this, we have 5 numbers here, so what we have to do to find x, we can rewrite it as xi equals x1 plus x2 plus x3 plus x4 plus x5. So all 5 x's divided by n. We can get now 10 plus 5 plus 2 plus 7 plus 25 divided by 5. So when we do the sum, so if we do 10 plus 5 plus 2 plus 7 plus 25, we get 49 divided by 5, and our decimal for that is 9.8. So therefore, our mean is 9.8, right? So as we move on, right, our mean is our collection of values, which is fixed by the constant sample to sample. So as we move on, we're going to do the measurement of variability. Examples include daily temperatures of 2 cities. So let's say we have 2 city temperatures in Celsius, Vancouver and Toronto. So as we do this, right, we have these 2 data sets. You can tell that Toronto has a larger range. So because it has a longer range, we can determine a couple of things by this, right? So as we determine a couple of things by this, we can determine, right, which one has a small and which one has a larger. So in this scenario, we can determine Vancouver has a smaller variability due to the average of our mean. So if we calculate the mean values, let's say of Vancouver, so we have -5 plus, so we have 5 plus 2 plus 6 plus 11 plus 15 plus 18 plus 19. But so we actually have to minus 5, I apologize. So -5, 2, 6, 11, 15, 18, 19. We get an x value, mean value of 66. But in Toronto, right, if we do these values, right, so we have -30, minus 10, plus 10, plus 15, plus 23, plus 32, we get a little bit of a higher value, right? So because it has a larger range, it means it has a higher variability, and because this one will have a lower variability. So as we go into variability, it's very important when we go through our sample variance, which is denoted by S squared, and our standard sample deviation, which is denoted by S. We can determine when we use I in the deviation, we can determine that the x value, xi, minus the actual mean of the said values. So it's xi minus the mean of the values, all right? So to write this formula, we're going to write out, remember, all formulas in red. So the formula for S1 equals, right, 1. So let's say we have 1 over n minus 1 with the sum of all values of n, I equals 1, xi minus x squared. So if this will want to be a little bit more important, so I'm going to start this because this one's a little bit easier to explain. We have x1 minus the mean squared plus x2 minus the mean squared. And then we can determine this with all the values of x, let's say x infinity and xn squared of the mean. And when we divide this now, we're going to take the same thing we found up here and do n, where's the value of all the numbers. Well, how many numbers we have? Minus 1. To get our sampled standard deviation, we take this s and we square root it to get our sample standard deviation, right? Some notes from this, where we conclude is we can square the values of xi minus xn. This is due to the fact that all the differences must be positive. So an example of this, right? So if we go up here, so example, let's say we have an xi value of -6, but we have a mean of, let's say, 10. So if we do this, we have 6 minus 10 equals -16 squared. When we square it, it turns into a positive. So -16 to the power of 2 equals, now instead of negative, we positive 256, right? So that's why we square all the differences must be positive. All right, so it's very important when we're doing this. When we square root it, it's always going to be positive. All right, so as we move on, I'm going to go over an example. So we have to find our sample variance and our standard deviation in our data set that we had earlier today. So we're going to go over our sample S squared, so standard deviation, right? In this scenario, remember it's going to be x1 minus x squared plus xn minus the mean squared divided by n minus 1. So when we do this, this will equal, right, let's say we do it for, let's do it for Toronto, right? When we do it for Toronto, just to keep it on Vancouver, you can practice on your own. So for Toronto, we have, it's like 7 values. We have, right, so first we have to calculate our mean, right? So our mean of Toronto equals -30 minus 10 plus 0 plus 10 plus 15 plus 23 plus 32 divided by 7. So 1, 2, 3, 4, 5, 6, 7. Our value we can get, right, if we do the quick math, plus 0 plus 10 plus 15 plus 23 plus 32, right? So we have an average temperature of 5 point, sorry, I just clicked it off my calculators, I apologize, is 5.71 if we're considering the negative temperature. So if we're considering these two as to be negative. So that's our x value. So now we can add this into our formula. So we can do, right, -30 minus 5.71 squared plus -10 minus 5.71 squared plus 0 minus 5.71 squared plus 10 minus 5.71 squared plus 15 minus 5.71 squared plus 23 minus 5.71 squared plus 32 minus 5.71 squared, dividing this by 7 minus 1. So if we turn this over to this point now, so we can do the math. So we do negative 30 minus 5.71, and to the power of 2, we get 1,275.20 plus our next value of negative 10 minus 5.71 to the power of 2, 246.80, right, plus 5.71 to the power of 2, 32.60, then plus 10 minus 5.71 to the power of 2, which equals 18.40, plus 15 minus 5.71 equals 86.30, plus 23 minus 5.71 to the power of 2 equals 298.94, plus 32 minus 5.71 to the power of 2, which equals 691.16. Divide this by 6. So our answer for our s squared is 1275.2 plus 246.8 plus 32.6 plus 18.4 plus 86.3 plus 298.94 plus 691.16. All that divided by, so which is 2,649.4 divided by 6 equals a standard variance of 441.56. So you notice this value is quite big. So for our s value, remember we're square rooting our variance, so we use square root 441.56. So our answer, so root 441.56, we get our standard deviation is 21.013. Awesome. So as we do this, remember we're using all of our x values, minus by that by the mean, divided by n minus 1 to get a sample standard deviation of s squared. All right. So as we go down, we have to note just for different things for our data. So notes for data, right? So we have to notice that large s value, so our sample variance, implies large variability. Right? As we have our data going in. So the population variance, so remember, so now we have a new topic, so population variance, as going on from the other unit, right, includes this symbol, squaring it, 1 over n, which remember, we said standard for population, right? The sum of all the n values, remember I still equals 1, xi minus mu squared, which is mean, or the sample, right? This can also be go for standard deviation, which equals squared, right? So this is our population standard deviation, right? So we still have the divisor of, right, the difference is, you'll notice that there's no n minus 1. So we rather use a sample size of just n. All right, so we have our next one, which is just summary of the symbols. All right, so we're going to use on our, make a little chart. So make a chart here, make a chart here, just to organize them all. Make a chart here, one right, going across the middle. Yeah, why not? We'll put an arrow, just keep it as that. All right, so we have population, and we have our sample. We can put another line here. Awesome. So remember, our mean in our population is mu, while in sample is x with a hat. Our variance, now, as we go down, our variance is squared. So this symbol squared, and a sample squared. In standard deviation, it's slash squared and then s. So you see that these values relate in some form or another. All right. So as we move into chapter 2, we're going to move into more advanced stuff. So I'll be also posting some homework that will help you going on through chapter 1. Hope you guys have a great day.